Now that we've looked at several examples of a two-sample t-test, I want to consider a new scenario. So suppose we're interested in comparing prices at Walmart and Target for health and beauty items. There's kind of a couple different ways we could set up that research. If we were looking to use a two-sample t-test, the way we might approach that is to get a list of items at Walmart, pick 30 at random and find their mean. And then separately get a list of items at Target, get 30 at random and find their mean, and we could compare those. It's kind of one approach. Another approach might be to see what items they have in common and then pick 30 at random from that list and get the price from both Walmart and Target. Okay, so let's take a little closer look at both of those options. So if we do two independent samples, like we would use for a two-sample t-test, what could end up happening is that they don't have similar items. So maybe we ended up with one list by luck of the draw that ended up with less expensive items, and another list that ended up luck of the draw with more expensive items. It makes it really hard to tell if it's just the items themselves. So we picked hair coloring or razors or something that might be more expensive versus like floss or a toothbrush that is less expensive. So, some of that could be going on and could be really influencing the results of our research. If we look at this other approach with paired data, we're looking at items they have in common. So maybe they both sell Dial body wash. Then we can compare the price at Walmart and the price at Target. And we're really kind of comparing apples to apples then. And so what we would do with that is we would subtract those two, and we're going to get what's called a list of differences or a column of differences. And you can see that over on the right-hand side. So I've just subtracted those two. And then what I did was I found the average for the differences column. So I ignored the Walmart data and the Target data. And I just looked at where I subtracted those two, and I found the average and the standard deviation there. Okay, so question for you that's in your notes is, which of these do you think is going to be a better or give us more accurate results in comparing these two companies? Let's go ahead and pause the video for a second and answer that. Okay, so when I'm looking at this, the paired sample is going to give us more accurate data because I really am going to be able to compare the same product and its price at both stores versus, I might have just ended up with cheaper and more expensive items by random sampling, luck of the draw, those things happen. So this paired data is going to be much more effective at telling us whether those prices are cheaper at one store than the other.